So this video is about misleading graphs and misleading statistics, including things like bias in surveys. I like to call it don't believe everything you read, because statistics can be used to convince you of things, and often the exact same statistics can be used and manipulated in multiple ways to look convincing for one side or the other. So for example, we have two graphs here. They show the exact same information. We're demonstrating the number of cookies that a gourmet cookie shop sold each month. By the way, these letters down here are abbreviations for each of your months: January, February, March, and so on. Notice the y-axis, the dependent variable, is number of cookies sold in the thousands. So when we see 1, that's really 1,000, and so on. These graphs actually show the exact same data. But when you compare them, the graph on the left makes it look like the company is doing a lot better than the graph on the right. What's making the difference here? Why are they not looking exactly the same? Everything matches except for the way the y-axis was numbered, the scale on the y-axis. There are two important changes. One is that, first of all, this counts by 2s, and this one counts by 1s. So I've compressed the data vertically. But also, this graph didn't start at 0. It started at 2. So it actually left out a whole row. It's not that you can't do that, but remember, if you're going to do something like that, you need to still start at 0 and show a break in the graph. In this case, there's no reason to show a break between 0 and 2, so really they should have just started at 0, moved all of these numbers up one space. So same exact information, but this one makes it look like the cookie company is not doing as well. Let's take a look at another example. So here, first of all, this graph is probably not so good because it's missing a label and it's missing a title, but we kind of fill in that information over here on the left. This graph shows how much money various high school students earned over summer vacation. So each of these bars would represent a different student, right? And it's showing you how much money they earned over summer vacation. Obviously not a lot, but still. Would you call this a misleading graph? Well, hopefully you said yes, you would, because this graph is misleading. It's missing a big chunk of information, and I don't mean the names of the people that these bars are representing. I mean it's missing from 0 to 20. There should be more space down here at the bottom of the graph showing from 0 to 20. And here's why that's important. It's not that you can't read the tops of these bars and see the numbers that they earned, but it's giving you a misleading impression because the relative size comparison is thrown way off. This person obviously earned the least, right? And this person earned not much more than they did. And when I compare that to the person who earned the most, with the way the graph is designed, it looks like this person earned 6 times as much as these two people, because this bar is 6 times as tall as these bars. But that's not actually true. If I extend these bars down, this is where you have to put up with my not so great drawing skills. If I extend these bars down to where 0 would be approximately, like they should have been, and then I start comparing their relative sizes, then I'll see this person still earned the most, but it wasn't 6 times as much as this person over here. He earned maybe a little more than 2 times as much. And again, our numbers back us up, right? 80 compared to 30, and maybe this person earned like 28 or something like that. So a little more than 2 times as much, but certainly not 6 times as much. When we don't do our graphs accurately, the visual impression that they leave is going to be misleading. Again, we have a side-by-side comparison of two graphs that's showing the exact same information. In this case, we're talking about employee productivity levels for several years in a certain business. If you look at these two graphs, which one do you think is the misleading graph? The truth is, I kind of think they're both misleading, each in their own way. When you start to compare them, first of all, right, the years are the same, 91 through 95, but this one, these are more horizontally spread out. When I look at the y-axes, this graph again skips from 0 basically to 30 without showing a break. And if you're going to skip, that's fine, but you need to have the 0 there and show a break. Then they count by ones from 30 up to 38. This has the effect of making it look like the data is making incredibly large gains because visually it goes from as low as possible to as high as possible on the graph. In graph B over here, they did sort of skip 0. For some reason, this bottom line, based off of the scale on their y-axis, would be at 5. And I don't know why they left that out, because that doesn't really make a difference at this point. But that is a problem. They left out 0. But this time they did not include any break and skip ahead. They just went counting by 5s basically for every line, or 10 every other line. And between that compressed vertical axis and the elongated horizontal axis, it has the effect of making this data look like they've made hardly any gains at all. That line looks almost flat. You can see there is a slight increase, but not nearly as much as the visual increase that's happening over here. To me, this looks like maybe you've got an employer and an employee arguing over should the employees get a raise or not. And if you're the employees, you want to make it look like your productivity level is rising and we're doing better and better and we're earning more and more money for the company, so we should get a raise. And instead, the company's like, well, over these last several years, really you haven't improved all that much and you're almost the same as where you started. So again, depending on how you present the data, it can be pretty misleading. Here's your first do now question. Is this graph that I've provided for you here misleading or not? And explain why or why not. Pause while you answer this question. So what did you think? Is this misleading or not? First of all, I probably should have had a break here between my 0 and my 5 feet, but that's not going to be the big difference as to whether or not it's misleading. This graph is misleading, and it's because of this axis. Notice my first bar represents from 5 foot to 5 foot 3 inches. Then I go from 5 foot 3 inches to 5 foot 8 inches, from 5 foot 8 to 5 foot 10, from 5 foot 10 to 6 foot 1. These are not equally spaced intervals. This interval has the most students in it, but it also has the biggest range of included heights. So that's not necessarily a fair comparison. Now let's move on to talk about bias. What does bias mean? There can be some slight different interpretations here, but when we're talking about bias with statistics, we're talking about collecting data in such a way or representing data in such a way that it's not a good random sample of people that you're getting information from, that it's kind of skewed towards a certain type of people, towards a certain group of people, or where it's steered away from and it's leaving out a certain type or a certain group of people. So let's say the mayor of Dallas conducted a popularity poll by giving a questionnaire to everyone stopping at the mayor's campaign headquarters. Why would the results of that survey not be valid? Well, right, if they're already going to the mayor's campaign headquarters, chances are they support the mayor. So that's leaving out a big chunk of people. That's also not a very random sampling. You're talking about people who tend to be politically involved, so much so that they are going to seek out the campaign headquarters, possibly to volunteer, maybe to get more information, maybe they haven't decided yet to vote for the mayor, but that's leaving out a whole lot of people that are too busy to go during the day, that would root for one of the mayor's opponents, right? So that's not a valid survey. What's going to be a better way for the mayor to get a representative sample? There are a variety of ways that you can do this, but again, the key is you want a nice random sample. You want it to try to be well dispersed amongst whatever group of people you want. So if you're asking everyone in Dallas, you want to try to find a way to give everyone in Dallas the opportunity that maybe they could be involved in this survey. Let's take a look at something maybe a little more familiar to us. Let's say that you wanted to find out what parents thought about our school principal, and you were going to take a survey of a group of people You obviously don't want to necessarily take the time to ask every parent of every student here at Keeling. So you're going to ask a smaller group to represent all of the parents at large. That's a sample. A sample is a subset, a smaller group, whose responses are hopefully going to reflect and represent the entire group. Which one of these is going to be the most biased sample if you're trying to find out what parents think about the school principal? Pause and figure that out. All right, so what did you think? The answer is D. This is going to be the most biased sample because if you're asking people that are coming out of the magnet director's office, chances are these are parents involved in the magnet program. That's leaving out everyone in our neighborhood program. Now, something else to talk about. Sometimes completely correct information can be used in misleading ways. So let's say you have a housing development with 5 different home models and their prices are $375,000, $400,000, $125,000, $380,000, and $410,000. Then the developer places an ad in the paper that says you should totally come and check out our neighborhood. The average price of our homes is $338,000. Why is that misleading? That's not inaccurate. If we were to average these 5 numbers together, we would get $338,000. But why is that maybe not the best representative number of this set of data? Well, if we compare this to all 4 of these numbers, only one number is less than the average, while the other 4 are more expensive. So this is misleading because while it is technically the average, it's being pulled down by this outlier that's much less expensive than the other home types. Also, what if there were only 5 houses that were this price, and there were 20 houses at all of these other prices? Would this truly be the average then? It would be the average of each of the different types of prices, but shouldn't you take into consideration how many homes there are available at each price? So this is what I'm saying. Lots of things can be used in misleading ways. Last, do now. Think about this statement. The revenue for ski resort A for November and December was $6,600,000. The revenue for ski resort B for January and February was $8,300,000. So therefore, ski resort B is more successful. Pause now and tell me what's wrong with that statement. Well, what's wrong is it's not a fair comparison. November and December versus January and February. First of all, if we're talking about ski resorts, there tends to be more snow in January and February. November and December, that's really mainly the end of fall and the very beginning of winter. And yes, there can be some snow there. But the more time that there has been for snow to fall and develop, the better the skiing is going to be. Secondly, what tends to happen in November and December? We have several holidays where people go and spend with their relatives, and they might be less likely to take a skiing vacation when instead they want to go and spend Thanksgiving or Hanukkah or Christmas with their relatives. In January and February, however, we don't have those type of family holidays, so people might be more willing to go skiing on a weekend. So this is not a fair comparison for us to declare that ski resort B is more successful unless we try to make everything as balanced as possible.